In this fourth video of our semester review for Algebra 2, we're going to revisit this notion of solving an equation by factoring. With problems like number 28 and 27, you'll notice that the expression on the left side has already been factored. And this is meant just to remind you of the fact that when we have factors that multiply by one another and their result equals 0, then it's very easy to identify the solutions to the original problem. Because if we pretend that we had two numbers, a times b, and the result ended up being 0, well, we know that either a is equal to 0, or b is equal to 0, or both are equal to 0. That's the only way that we can get two terms, or two elements to multiply together to equal 0. And that's exactly the case that we see here with number 28. If m plus 4 times m plus 1 is equal to 0, then either m plus 4 is equal to 0 or m plus 1 is equal to 0. Essentially, anytime that we have factors that multiply to equal 0, we set each of those factors equal to 0 themselves and then continue solving the problem. By doing so, this produces much easier equations to solve, and it presents all solutions that are possible for a given equation. So what number does it take to add 4 and still equal 0? Well, that number is negative 4. What number plus 1 equals 0? Well, that number is negative 1. And as it turns out, for problem number 28, we actually have two answers, both negative 4 and negative 1. Now, the answer sheet on this handout likes to abbreviate the results, and mathematically speaking, we would say that m is equal to the set of numbers, negative 4 and negative 1. But on the answer document itself, it doesn't have the m equals component. It just lists the set of numbers in between these braces. So if you see an answer that looks like this, that's okay. The solution is represented by these two numbers here. With a problem like number 30, we don't have a factored expression on the left, but we do have an expression that's equal to 0, which is good for us. Anytime that we have an equation equal to 0, we can use techniques that we've learned to simplify this expression on the left-hand side and hopefully turn it into a factored result. In the last video, we talked about factoring standard trinomials, and in this case, this is a perfect opportunity to use that technique. Two numbers that multiply to make 5 that add or subtract to equal negative 6 are negative 1 and negative 5. Now we see the product of two factors that equals 0, so therefore either factor or both is equal to 0. When does x minus 5 equal 0? And when does x minus 1 equal 0? Those are the next two questions we have to ask. This occurs when x is equal to 5. And this occurs when x is equal to 1. There are our two solutions, 1 and 5. And now for number 32. This time we have an expression that equals another number, and that's not very good for us to solve this particular problem. So the first thing that I'm going to do is I'm going to subtract 3 from both sides of the equation, and this will allow me to report an expression equal to 0. Now I'm going to factor the left-hand side, and what I notice here is that there is a GCF of the number 4. 4 is common to all three of these terms, and after I divide all three of those terms by 4, I'm left with x squared minus 4x plus 4. And I'll continue to factor. Again, we have a standard trinomial inside of the grouping symbol here. So I'm going to report x and x at the beginning of these two binomials. And I'm looking for two numbers that multiply to make positive 4, that add or subtract to make negative 4. And those two numbers are going to be negative 2 and negative 2. So when does this equation equal 0? Well, that happens when 4 is equal to 0, when x minus 2 equals 0, and when x minus 2 is equal to 0. Now this is kind of interesting because, well, we have two duplicates here. X minus 2 equals 0. Well, that happens at 2 And again, at 2, that answer occurred twice, so we don't need to report it both times. We'll just report it once as a final answer. And then lastly, we've got this factor here, which is a bit unusual to consider, but it's a good idea to do so in case it's a bit more complicated of a common factor originally. Can the number 4 ever equal 0? Well, the answer is no. So there's really no solution that comes from that factor. But we do have solutions at x equals 2 and x equals 2. So sometimes you'll see that reported just as a single copy of 2. I think that's a good stopping point for this video because in the next one we'll pick up with solving quadratics using the quadratic formula. And if you recall, we programmed our TI Inspire calculators in the classroom in order to complete this very quickly. So in the next video I'll walk through that procedure again, and we'll complete those problems 33 through 42 in the next one. Thanks for watching.